Okay, good evening. My name is Tim, and I'd like to talk to you a little bit about structured bindings. And I should actually turn this on. There we go. I learned about structured bindings, specifically their implementation. This is slightly offset, but I hope it's visible enough. I learned about it in Nicola Yasada's book, which is an awesome book. He does a great job of explaining how structured bindings work internally and how you can implement your own support for structured bindings for your classes. And it's been quite interesting to read about this and experiment with it. And most blog posts that I've seen out there, they generally show some example of, I have a class, I have some data members, and my structured bindings, they return those data members. But when I read this, I realized you can do all sorts of interesting things with structured bindings. So let's actually start with implementing them for our type, my decomposable type. We first tell the compiler how many values we actually decompose into. So here I have 2, but we could of course compute this at compile time using a const expr function or some other value we get from somewhere else, like using traits, for example. Next up, we actually tell the compiler what the type of each of those bindings, those elements, should be. We could do that by hand by specializing it for each value of n that we need to specialize it for, or we could use decal type here, so we can let the compiler use it for all of the different values of n. Sadly, part of that slide is cut off, the danger of using Linux. So I like the decal type approach because it lets the compiler do a little bit more work, and it's less code to write. And I also have only one place where I need to change the return type, which immediately affects what the type is. Finally, we implement get, which can either be a member function of your class, or a member function template, or a overload of stdget that takes a value of your class. And here you can effectively do pretty much anything that you can do in a normal function. So you can return a constant value, you could return the nth Fibonacci number, you could return a random value if you want. And this is actually quite powerful. You have a lot of creative freedom that you can apply here. And that's, in my opinion, quite a lot of fun. So you would use it like this. This, unfortunately, doesn't show the rest of the code, but well, above, of course, is how you would use your structured binding. And to describe what happens down here, you get a unnamed instantiation of your type, and you get a new variable for each of your structured bindings, which would be visible if it would render correctly. It's perfectly visible on my lap. So I started thinking about how I might use this in different ways. You can take an integral value and decompose it into its separate bytes. Or you could do the same with an IEEE float. You can just access all the different components, which immediately got me thinking about maybe using this for NaN boxing, where you can decompose it into the actual type and the value you have. And that goes into the same idea with the Golang-like error handling. So you have a function that returns some kind of expected value, which is either a T or an E. It really just stores one value, but then at the point of use, you decompose it into a value and an error. You inspect the error and you handle it or use the value. Not sure we want this type of error handling, but it's an interesting API design choice you can make. So for the decomposing of an integral, I have a small example implementation. So this is what it might look like. You have your bytes of struct, in this case, that takes an integral value, and it can decompose it into 4 separate bytes. So that class might look like this. Luckily, most of this is actually on screen now. We take the value, and our function of get shifts it appropriately and returns the byte that we're actually interested in. We can use size of to figure out how many of the elements we actually need. And then we once again use decal type to figure out the exact value that we want to have. Of course, in this case, it's just a byte. But you can imagine you can use all sorts of different ways you can combine this. So hopefully I've shown you that there's not all that much code you need to implement your own custom structured bindings. There are plenty of interesting and very funky ideas that you could potentially implement with this. And I hope I've kind of inspired you to play around with it, look into it more, and hopefully come and present your ideas next year. Thank you.